In today's lesson, we're going to continue with section 4.5, elementary differentiation rules, and we're going to look at the sum and difference rule. The sum and difference rule is used to find the derivative if two or more functions are added or subtracted. For example, if y equals f of x plus g of x, then the derivative, which is written as y prime, is derivative of f plus the derivative of g. Similarly, if two functions are being subtracted, then y prime would be the derivative of f subtract the derivative of g. Let's take a look at a specific example. In our first example, we have f of x equals 9x to the 8th minus 8x to the 7th plus 4 to the 5th. We want to find the derivative. Well, the notation we use for derivative is f prime of x is equal to, now I'm going to use the power rule, so the derivative of 9x to the 8th, I bring the 8 out front, that becomes 72, and my exponent on the x drops by a power of 1. I bring the 7 out front, so 7 times negative 8 would be negative 56, and my exponent drops by a power of 1 to become x to the 6th. Again, having a little trouble with my pen here. Okay, x to the 6th, and 4 to the 5th is a constant, and the derivative of a constant is 0, so this would be my final answer. All right, let's try this one. So I have the product of two binomials, and before I can take the derivative of this, I would have to expand this product and turn it into a sum and difference of terms. So if I multiply, I'm going to get x squared. My middle term, when I collect like terms, will become a negative x, subtract 12. So that's my product. Now I can take the derivative. So again, f prime of x is going to equal the derivative of x squared. I bring the 2 out front, subtract 1 from the exponent, and that's 1. And the derivative of negative 1x is simply the constant negative 1, and that is my derivative. All right, in our third example, we have some radicals to deal with, and like we did earlier on in section 4.5, any variable that is under a radical, you must write it as a variable to a fractional exponent. So the first thing I'm going to do is I'm going to break up my fraction into root x divided by root 3 minus 2 over root x plus 6. Now I'm going to change all of my variables that have radicals to fractional exponents. So that becomes x to the 1/2 over the square root of 3 minus this bottom guy becomes x to the 1/2, but when I move it up to the top, it becomes exponent negative 1/2, and my constant 6 doesn't change. Now before I go to the derivative step, you might want to rewrite this guy here, because that root 3 on the bottom is really the same thing as a coefficient of 1 over root 3, x to the positive 1/2, minus 2x to the negative 1/2, plus 6. Now this is still my function f. To find f prime, I'm going to use my power rules that we used earlier. Okay, so f prime is going to equal, the 1/2 comes out front, and a 1/2 times 1 over root 3 is going to be 1 over 2 root 3, and if I subtract 1 from 1/2, I get negative 1/2. I bring my negative 1/2 out front. Negative 1/2 times negative 2 will be plus 1, and if I subtract 1 from negative 1/2, I get negative 3/2. And the derivative of 6 is a constant, so that would be my final answer. Now I left negative exponents here in my final answer. Some textbooks will force you to move those back down to the bottom to make them positive, but when we're asked to find the derivative in this case, I'm just going to leave them as is. Okay, in this next example, we have a binomial being divided by a monomial. Okay, so right now, the only rule I have at my disposal is the sum and difference rule, so I'm going to break this up into the difference of two terms. So I'm going to take each term in my numerator and divide it by x to the 4th. Now I'm going to use my laws of exponents, x squared divided by x to the fourth. Remember, you leave the base, subtract the exponents. Negative 3, x to the third divided by x to the fourth is x to the negative 1. Now we're ready to take the derivative. So using the power rule, the negative 2 comes out front. I subtract 1 from my exponent. The negative 1 comes out front. I subtract 1 from my exponent, and that would be my derivative, which represents the slope of my tangent line. Okay, this next question, slightly different than ones we've seen so far. We are asked now to find 2 points, so 2 coordinates on this graph where the slope of the tangent line is 6. Well, as soon as you see the phrase slope of the tangent line, you have to be thinking derivative. Okay, so the first thing I'm going to do is I'm going to take the derivative of my function, which is 3x squared plus 6x subtract 3. And now, since I'm looking for coordinates, I'm going to be solving for x. So I must know what f prime is, and f prime is my slope, and the slope is given to me as 6. So I replace f prime with 6. And now I'm solving my quadratic equation. So I set it equal to 0. So it's going to be 3x squared plus 6x minus 9. To make my math easier, I'm going to factor a 3 out. I'm left with x squared plus 2x minus 3. So this ends up being x plus 3 or x minus 1. So my 2 answers for x is either x is negative 3 or x is equal to 1. So now, I just have my x coordinates. They want the coordinates, so I need the y coordinates for each. So all I'm going to do is I'm going to take each of these x coordinates, and I'm going to plug them back into the original to find the y coordinates. So negative 3 is going to equal negative 3 cubed. Okay, this pen is really acting up on me here. Just bear with me. Try it again. So this is going to be f of negative 3 is equaling negative 3 cubed plus 3 times negative 3 squared minus 3 times negative 3. If we work this out, I get negative 27. The middle term becomes positive 27 plus 9, so this equals 9. So therefore my coordinate is the point negative 3 and 9. Now I do the same thing when x is 1. So I'm going to plug 1 in for my value of x in my function to get 1 cubed plus 3 times 1 squared minus 3 times 1. And if I collect like terms, this works out to be 1. So my next coordinate is the point 1, 1. So if we look at those 2 points and we drew a tangent line, we would get the function, or we would get to have a slope of 6. All right, let's take a look at the next example. In the next example, it's saying explain why the line with a slope of negative 2 could not be tangent to this curve. So again, I'm given a slope of negative 2, and I'm talking about tangent to a curve, which means the derivative. So let's proceed like we did in the previous example until we run into ourselves into a little bit of a glitch, because it's saying explain why this can't happen. So first of all, I take the derivative, and the derivative would be x squared plus 1. That represents the slope of my tangent line. Well, they're saying, why can the slope not be negative 2? So let's plug negative 2 in for y prime and see why it can't be negative 2. Well, if I try to solve for x, I would get x squared is negative 3, and now to solve you'd have to take a square root, and right away bells and whistles should be going off because you cannot square root a negative. So therefore it is impossible that I have a tangent line, with a slope of 2. Because I cannot find the next coordinate where the slope would be -2. All right, one more example. In our last example, we are asked again to find the point on the equation where the slope of the tangent line is parallel to this line. So we have a lot of information going on here. Again, I'm asked to find a point. Okay, so anytime you're asked to find the point on the tangent line, they must give you the slope somehow. Well, they're telling us the slope of the tangent line is parallel to this line right here. So from Math 10, if I could write that in the form y equals mx plus b, I can find my slope. So to do that, I'm going to subtract the 4x to the other side, divide everything by 2, and I'm going to get -2x plus 4. So this becomes -2x plus 4. So therefore, the slope of this line is -2, which means that the slope of my tangent line also has to be -2 because my tangent line and this line are parallel, and we know from Math 10 that parallel lines have the same slope. So now, if I have an equation and I want to find the slope of the tangent line, I take the derivative, which would be 2x plus 6. Again, my slope is -2, so I would substitute it into the derivative. I subtract the 6 over, divide, and I get an x-coordinate of -4. So if I draw my tangent line to this curve at -4, my slope should be -2. But it wants the point, which means I need the y-coordinate as well. So to find that, I just plug 4 back into the original equation, or -4, sorry. So -4 squared plus 6 times -4. So this works out to be 16 minus 24, which works out to be -8. So therefore, the point on this function where the slope of the tangent line is parallel to this line, which is -2, happens at this point right here. All right, I hope that made sense. There is your assignment for the last part of section 4.5. So take a look at the web page. All the answers for the assignment are posted, and good luck.